All right, here are the results for 3 and 4 with the derivatives of each of these functions, f and g. Found the composition h of x in each of these cases, and then found the derivative of the composition of those two functions. And I can see, like when I look at 3, it's not just as simple as this derivative times that derivative, because that would be 6x squared. Definitely not what I get here. When I multiply these two things, my powers don't even match up. It's not even close. I got x cubed multiplied times x. It'd be x to the fourth. It's not happening. Okay, so let's see. We're talking about a composition of functions. And remember that when we're looking at the gears, it is the output of one gear is supposed to drive the next gear. So if you look right down here at the bottom, here's a little hint. If f prime of x is equal to, I said f prime, it's h prime. If h prime of x is equal to f prime composed with g of x, notice that this creates another composition where g of x is substituted for x and f prime. We want to go ahead and perform that composition and see, is that the derivative? If not, then maybe we got to fix something else. I'm going to switch colors here. Okay, let's try this. Let's try f prime composed with g of x. So we're going to take this g of x, and now we're going to compose it with this one. All right, well, there's nowhere to stick it in, which means that it's just equal to 2. All right, now let's compare that to this h of x function right here. If I try to compare this, notice that, I'm missing something. What am I missing? I'm missing the 3. I'm missing the 3, which is the derivative of the g of x function, so times 3 to get the 6x. Let me fix this arrow right here. This should have been an arrow. Okay, anyway. All right, let me try that again over here on number 2. I'm trying f prime composed with g of x. The composition of g of x inside of f prime of x. I would have 2 parentheses 3x to get 6x, and now let's compare that to the derivative. What am I missing? It's 3x, but I need 18. I need to multiply that by 3. So times 3. Oh, look at that. It's right there. There's where our 3 is to get 18x. Okay, all right. You starting to get a pattern here? Maybe, possibly. Okay, let's try again. F prime composed with g of x. We'll take this 2, and we will... No, that's not correct. We're going to take the 2x and plug it into the derivative of f, the exterior function. So this is 3 composed with 2x, which I will square to get 3 times 4x squared, which is 12x squared. And now whenever I compare that to this 24x squared, what am I missing this time? I'm missing, it's 2 times. I need a times 2 here. So times 2, where's that 2 coming from? Of course, it's coming from g prime of x in order to get our 24x squared. Okay, one more. Maybe we'll be able to put it all together right here, if you haven't already. Okay, so let me do the composition again. F prime composed with g of x. Take this g of x function, stick it into f prime of x. I'd have 4, open the parentheses, x squared cubed gives me 4x to the 6th. Okay, what am I missing? What am I missing? Let's compare this to this guy right there. Missing a 2 and an x. I need to multiply it by 2x. Is there a 2x any place on this piece of paper? Yes, this digital piece of paper, it's right there. Bam. It's g prime of x to get 8x to the 7th. All right, putting these pieces together, we can see that no, the derivative of our composition of functions is not just simply f prime composed with g of x. It is a product of that and the derivative of the interior function. It was the derivative of the interior function. So here is the way we write the chain rule. H prime of x is equal to the derivative of the exterior with respect to the interior multiplied times the derivative of the interior. And that, my friends, is the chain rule. In the next video, we'll actually use the limit definition in order to prove that.